Hello all, welcome to my channel. In today's session we are going to learn about instruction set of Intel 8051 microcontroller. Many students get confused to learn or to memorize instructions with examples. In 8051 we have various types of instruction set and also instruction set groups. Today I will discuss both in detail along with some key points which are to be included when you are answering a long answer for instruction set 8051. Instruction is actually defined as a command given to the system or a computer. When you are referring it as a system or computer, it is understood that you have to take it for both processor as well as controller. So instruction is a command given to controller to perform a particular task on the given data, which is binary. The set of instructions written in a sequence is called a program. And when 8051 is considered, there can be up to 2 to the power of 8. That means 256 instructions possible in 8051 family of microcontrollers. And in Intel 8051 microcontroller, there are almost 111 instructions to operate on either 8 or 16-bit data or code. Now these instructions are categorized into 3 types basically: 1-byte instruction, 2-byte instruction, 3-byte instruction. Now a simple instruction consists of just an opcode, whereas other instructions may include one or more operands. 1-byte instruction, if you consider as an example, it contains only the opcode. 2-byte instructions contain opcode in the first byte and operand in the second byte, whereas 3-byte instructions contain opcode in the first byte and the operand can take either third or both third and second bytes. No need to elaborate 1-byte, 2-byte and 3-byte instructions in depth because already we have covered this with examples in 8085 microprocessor. Okay. Now coming to the groups of instruction set in 8051 microcontroller. As you can see here, there are 5 groups of instruction set: data transfer group, arithmetic group, logical group, Boolean manipulation group, branch control group. These are the 5 instruction set groups. Now if you get into the format of instruction, the format should be, or the hierarchy should be, first we have to write down the memory location, followed by opcode, followed by mnemonic, followed by destination operand and source operand, which will end with comment. The examples of instruction written in this sequence you can see in Masti and Masti textbook or in any other 8051 microcontroller textbooks like Kanitayala or Ajay V. Deshmukh. Now coming to the first group, data transfer group. The mnemonics associated with the data transfer group are as follows. I have shown the instructions, basic instructions which we use along with the comment. MOV stands for move data, MOVC stands for move code, MOVX stands for move external data, push, pop are stack operations where push is used to move the data onto the stack, pop is used to delete or copy the data from the stack, XCH stands for exchange data between 2 registers, XCHD stands for exchange lower order data between 2 registers. Now the various instructions, these are the perfect instructions which come under data transfer group. Those are move A comma Rn. The description for this instruction is move register to accumulator. In the table you can observe each instruction is also mentioned in bitwise size, byte-wide size. Like for example, move R comma N, move A comma Rn is a 1 byte instruction which holds a description move register to accumulator. Now move register to accumulator indicates the content of the register, of the particular register, will be moved into accumulator, which is an 8-bit. Okay. Now here N stands for 0 to 7, number 0 to 7. Because as we have learnt in the architecture, the registers in 8051 are all 8-bit wide. So it will have 8 registers starting from 0 to 7, R0 to R7. Move A comma direct will move the direct byte into the accumulator. Move A comma @RI. It will move the direct RAM address. It will actually go to the RAM address. @ indicates that it is an address of the register where the actual content is stored. Now it will go to the address, it will get the content and it will move into accumulator. Similarly, move A comma hash data. Hash indicates excuse me. In this instruction, hash indicates that the data is the direct operand to the controller. Like this, all the registers are given here along with push and pop, exchange. So I have discussed the basic mnemonics in the previous slide and all the instructions present under data transfer with comments in this table. Next, going to arithmetic group. We already know what are the basic operations under arithmetic mode. We can see the mnemonics here along with the comment. ADD is addition without carry. ADDC is addition with carry. SUBB means subtraction with carry. INC will increment the data by 1 bit. DEC will decrement the data by 1 bit. Mul is used to multiply. Div is used to divide. DAA is used for decimal adjust accumulator. The use of this decimal adjust accumulator is if you get any result in hexadecimal or in any other binary, in any other number system, if you are using this instruction, it will directly convert the result into decimal and it will store in accumulator, which is also called as register A. Now these are the various instructions under arithmetic group, like ADD A comma Rn adds the instructions of register, adds the content of the register with accumulator. ADDC A comma Rn means add direct byte to the accumulator along with the carry. SUBB stands for subtraction. INC stands for increment. DEC stands for decrement. Mul stands for multiplication. Div stands for division and DAA stands for decimal adjust accumulator. You can see over the 4th column the number of bytes each instruction holds is written. The next group is logical group, which holds AND, OR, XOR, clear, complement, rotate, byte left with carry, rotate right with the carry, and swap. Swap means exchanging the data of lower nibble and higher nibble. ANL stands for logical AND, ORL stands for logical OR, XRL stands for XOR, CLR stands for clearing the register, CPL stands for complementing the register. And this is again a table consisting of all the logical group instructions together. The last group is Boolean or bit manipulation, which holds the 1-bit instructions like clear bit, set bit, move a bit, bitwise AND, bitwise OR, and complement. These are the various instructions associated with bit or Boolean manipulation along with the comments and number of bytes. Last one is program branching group. In program branching group you have long jump, absolute jump, short jump. LJMP stands for long jump. AJMP stands for absolute jump. SJMP stands for short jump. JZ stands for jump to A if it is equal to 0. JNZ stands for jump to A if it is not equal to 0. CJND, compare and jump if not equal to 0. DJNZ, decrement and jump if not 0. NOP stands for no operation. Anywhere no operation will stand as an important instruction, because anything you write after the instruction NOP will not be executed. It will be considering out of the program. LCall stands for long call. ACall stands for absolute. RET stands for return from subroutine. RETI stands for return from subroutine as well as return from interrupt. JC stands for jump carry. JMP stands for jump to an address. JNC stands for jump if carry flag is not set. JB stands for jump if specified bit is set. JNB stands for jump if the specified bit is not set. JBC stands for jump if specified bit is set and also clear. These are the various program branch instructions along with the comments. So I hope this video will be helpful for you in order to summarize all the instructions together for a long answer. Thank you.